to Geology Watch with this urgent global seismic update. In the last 2 days, the Earth has shuddered. A rapid and powerful succession of 3 strong earthquakes has struck across 3 different continents, a dramatic sequence that has put seismologists on high alert. On the surface, this looks like a random series of seismic events, but for geologists, this 2 days window was a rare and revelatory moment. These were not the same type of quake. We have just witnessed 3 fundamentally different expressions of our planet's power, from the deepest part of the mantle to the brittle surface crust. And together they tell a story about the violent, restless state of our world. Before we dissect these incredible events, if you find these geological insights critical, please take a moment to like this video and subscribe to Geology Watch. In Argentina, the sequence began at 2137 UTC in South America. A powerful magnitude 5.7 earthquake struck northern Argentina, northeast of Santiago del Estero. In a typical quake of this magnitude, we would expect moderate to strong shaking felt across the region. But in this case, the surface impact was minimal. The reason? Its depth. The rupture occurred at an almost unbelievable depth of over 570 kilometers. This was not a crustal earthquake. This was a deep focus earthquake, a ghost quake, an echo from a dying tectonic plate being consumed by the Earth's mantle. To understand how this is possible, we must look at the colossal engine of tectonics off the coast of South America. Here, the Nazca Oceanic Plate is being forced under the lighter South American continental plate in a process called subduction. This is the force that has built the Andes Mountains. But as that plate is shoved deeper into the Earth, it doesn't just melt away. The cold, brittle slab of rock remains intact for hundreds of kilometers as it plunges into the superheated, high-pressure environment of the mantle. At a depth of 570 kilometers, the pressure is so immense that rock should bend like clay, not snap. The fact that earthquakes can happen here at all is a profound geological mystery. Scientists believe these deep focus quakes are caused by phase change faulting, where minerals within the descending plate are abruptly forced into a new, denser crystal structure, releasing an explosive burst of energy. This quake was the sound of a tectonic plate being crushed out of existence, hundreds of kilometers beneath our feet. Its energy was mostly absorbed on its long journey to the surface, but its existence is a powerful reminder of the immense forces at play in the deep Earth. Settled boundary in the Philippines. Just minutes later, at 2159 UTC, the focus shifted to one of the most seismically active regions on the planet, Asia. The Philippines was struck by a magnitude 5.3 earthquake east of Pasay. This quake was much shallower, at 87 kilometers, and was widely felt. Seismologists immediately identified this as an aftershock of the powerful magnitude 6.9 earthquake that shook the same region just 2 days ago. This is a classic and dangerous example of an aftershock sequence. The magnitude 6.9 main shock was the primary failure, the moment the fault finally slipped after decades or centuries of accumulating stress. But that rupture was not a clean break. Imagine a massive slab of rock breaking. The initial snap releases the most energy, but the edges of the fracture are now incredibly unstable. Stress has not been zeroed out, it has been violently redistributed, creating new high-stress points on adjacent parts of the fault. The magnitude 5.3 aftershock we saw today is the crust settling and adjusting to this new, unstable stress field. It is the sound of the fault continuing to break around the edges of the main rupture. These aftershocks can continue for weeks, months, or even years, and can sometimes be powerful enough to cause more damage than the main shock, especially to already weakened structures. The location is a critical part of this story. The Philippines sits in a geological crush zone, squeezed between the Philippine Sea Plate and the Eurasian Plate. It is a chaotic mosaic of subduction trenches and active faults. This entire aftershock sequence is a symptom of that larger, violent continental collision. And almost simultaneously, at 2157 UTC, the Middle East was rattled. Iran experienced a magnitude 5.1 earthquake northeast of Argentina. While its depth is still being confirmed, it is almost certainly a shallow, crustal earthquake. And as seismologists always warn, shallow quakes hit hardest. This is the third and most directly dangerous type of earthquake we have witnessed tonight. Unlike the deep echo in Argentina, a shallow earthquake, often occurring in the top 10 to 20 kilometers of the crust, has almost no distance to travel. All of its raw energy is unleashed directly at the surface. This produces the violent, high-frequency shaking that is so destructive to human infrastructure. Iran sits on another one of the world's great collision zones, where the Arabian Plate is relentlessly ramming into the Eurasian Plate. This continental pileup has crumpled the crust, creating the vast Zagros mountain range and riddled the entire region with the network of shallow, active faults. While a magnitude 5.1 is considered moderate, a shallow quake of this size can cause significant damage. The tragic 2003 earthquake in Iran was a shallow magnitude 6.6, and it completely leveled the city, claiming over 26,000 lives. It is a devastating reminder of the threat that lurks just beneath the surface in this region. So what do these three events, happening in such a short window, tell us? They are not connected in a way that one triggered the other. Instead, they are a powerful, simultaneous demonstration of the entire tectonic system in action. Three strong earthquakes, three continents, three different stories about the forces that shape our world. From the deep mantle echo in Argentina, to the unsettled plate boundary in the Philippines, to the brittle surface rupture in Iran. The planet is moving tonight.